Assalamu alaikum. I hope that everyone is good. Welcome to the sixth online class of maths, the first session, Unit 2, Theory of Quadratic Equations, and the topic for today is Solution of Simultaneous Equations. Let's understand what simultaneous equations are. A system of equations having a common solution is called a system of simultaneous equations. The set of all ordered pairs x and y which satisfies the system of equations is called the solution set of the system. As you can see here, two equations, y is equal to x squared plus 5x minus 9 and x minus y equals 4. In these both equations, we can see two unknown values x and y. So when we solve these equations for finding the values of x and y, so as a result we will have the values of x and value of y. So whatever will be the value of x for the first equation, for the second equation also value of x will be same. For instance, if the value of x for the first equation will be 2, so for the second equation also the value of x will be 2. Similarly, if value of y will be 3 for the second equation, so for the first equation, value of y also will be 3. So here we can conclude that these both equations can be called as simultaneous equations because they will have the common solution set, or in other words, they will have the same solution. Here we have exercise 2.7. In exercise 2.7, the questions are not only lengthy, but they also need rational thinking. Because in exercise 2.7, you will come across different types of equations. So you have to be very thoughtful that how you have to proceed for solving those equations. Because in some questions you will find that one equation will be linear, whereas the other equation will be quadratic. Moreover, in other equations or in other questions, you will see that both the equations will be quadratic. So you have to be thoughtful there that how you have to proceed for solving those equations. And it depends on practice. So let's see that how question number 1 is and how we have to solve it. In question number 1, we can see two equations are given and we are going to solve these simultaneous equations. The first equation is x plus y equals 5 and the second equation is x squared minus 2y minus 14 equals 0. So you can see here that the first equation is linear, whereas the second equation is quadratic. And we are supposed to find the value of x and y here. So you have to deal that equation first, which seems a little bit easy, as we can see that linear equation is easy to be solved, so therefore it is written that from equation number 1. What we are supposed to do here, we have to derive the value of x from one equation and we have to put that value in another equation in order to find the unknown values. So from first equation you can see here that x is kept separate and y has been shifted to that side. So we can have the value of x, but this cannot be the final value of x because it is in terms of y. You have to find the value of x which will be just number. It should not be any unknown value. So let's proceed it ahead. Now we can name this as equation number 3. So you have to, from first equation you have found the value of x and you have to put this value in equation number 2 in order to find the value of y. So let's put it here. Put x is equal to 5 minus y in equation number 2. Here is equation number 2. Instead of x, what is written? The value of it. 5 minus y, and because above x we have a square, so therefore square is written. Then minus 2y is written as it is and minus 14 is written as it is. Now we can see that 5 minus y and we have whole square above it. So we can apply the formula a minus b whole square. 5 square a square minus 2ab plus y square, and minus 2y minus 14 are written as it is. So 5 5s are 25 and 5 2s are 10y, then y squared, then minus 2y minus 14 as it is. So here now you are going to arrange this in quadratic form. We can write the quadratic term first, then we can see minus 10 and minus 2y will be minus 12y. Then 25 minus 14 will result in 11. Here we can see that we can have three terms, so we can apply here midterm partition. That by multiplication we get 11 and by addition or subtraction we get 12. So of course 11 1 is 11 and 11 plus 1 will be 12. As far as sign is concerned, so whatever sign will be here, you will brought down it as it is. And then 11y, then minus minus will make plus. So therefore we will be having minus sign here. 11y minus 11y and minus y will make minus 12y. Then plus 11 equals 0. Here we can make pairs and we can take common. Y is common there in the first pair, so y is taken common here, and 1y and 11 is left inside. Here nothing is common and we can see 1 can be the factor of both, so 1 is taken common here. Y is left, and since minus is taken common, so here will be minus, because minus minus will again make plus. If you factorize plus, so minus minus will make plus. Okay, here we can see both the brackets are same, so it can be written once, and y minus 1 is written here. Y minus 1 can 11 can be equal 0, and y minus 1 can also be kept equal 0. So one value of y can be 11 and the other value of y will be 1. Here we have two values of y because we have solved other quadratic equations. Okay, now we have found the values of y, but we haven't yet found the values of x. So we have, by putting the value of y in the equation where you can see that x exists in the very easy equation, means from the equation where you derive the value of y. So in the same equations we have to put the value of y here, so in order to find the value of x. So first put the first value of y, then put the second value of y. Put y is equal to 11 in the equation x is equal to 5 minus y. Here the value of y is 11, and by subtraction we will get minus 6. You have to put now the value of y as a 1 and you will get 4 as a result, the value of x. Now we can see here that the value of x is also a number, it is not in terms of y. So here we have the values of x and y. Make sure that you write this in ordered pairs. Why we are going to write the solution in ordered pairs? Because in ordered pairs we know that x come first, then y come later. So here if you will write this in ordered pairs, so everyone can easily understand that the first one is the value of x and the second one is the value of y. Otherwise if you will not write in ordered pairs, so anyone can be confused that which one of these is the value of y and which one is the value of x. So therefore we have to be organized and we have to write the answers in the ordered pairs. When you will write this in the form of ordered pairs, so no need to mention that this is the value of x and this is the value of y. Anyone having the concept of ordered pairs will easily understand that the first one is the value of x and the second one is the value of y. The first one is the value of x and the second one is the value of y. Fine. The next question is question number 4. Question number 2 and 3 is similar to question number 1. Therefore now, question number 2 is similar to question number 1 and question number 3 is same as question number 4. So let's solve question number 4. Here we have two equations, x plus y is equal to a minus b, and 1 upon a upon x minus b upon y is equal to 2. Okay. Here we can see that one equation is linear and the other equation is in fraction form. So this seems to be an easy equation, but this seems to be a complicated equation. So from the easy equation you can find the value of x, then you can put that value in equation number 2. But before that, before putting the value, you have to eliminate the fraction in order to make it easy. So from first equation we can derive the value of x. Can be kept alone, and plus y when shifted to their side, it will result in minus y. Now this will be then equation number 3. At the end you have to put the value of y in this equation in order to find the value of x. So let's deal the second equation, which is in fraction form, and we have to eliminate the fraction. So you can see here that we have x and y in denominator, and it can be LCM then. So or we can multiply with x and y every term in order to eliminate the denominator. So here we are multiplying equation number 2 with x and y. When it is done, so x is cancelled and ay is left, and here y is cancelled, so bx is left, and here we will have 2xy. Now you can see that the fraction is eliminated, and this will be equation number 4. Now we can put the value of x from this equation in equation number 4 in order to find the value of y, because when you will put the value of x, so there will be only y variables, and you can easily find the value of y. So put x is equal to a minus b minus y in equation number 4 here. Okay, a is written as it is, y is written as it is, minus b, instead of x, see the value is written, then equal to, and instead of x we can write, see here that the value of the value is written and y is written as it is. A into b, then you can see here bracket, so bracket shows multiplication, minus minus plus, b into b, b square, and minus minus plus by, then 2a minus 2b. You can see here 2 is also being multiplied and y is also multiplied, so 2ay and 2by, then you can see here minus 2y square. Okay, now in the next step we have arranged it in order to write this in quadratic form for further simplification. So we can see here that 2y square is in that side of the equation. Now we have brought it to this side of the equation, therefore it is with plus sign. Then we can see here that ay is written, means linear terms are written, ay, then with ay we can write minus 2ay, then plus by, and then we can write minus 2by. It will be with positive sign when brought to that side of the equation. Then at the end we can write the constant terms without any variable, minus ab plus b square. So you can see here that 2ay and ay are similar terms, so minus 2ay plus ay will result in minus ay, and 2by plus 1by will be 3by. Then minus ab plus b square are brought down as it is. Okay, here we can see that this is the quadratic term and this is the linear term. Here we can take y common and a minus 3b is left, and here we can take minus common, so this will be the constant term. Now this will be the standard form of quadratic equation, ay square, and then this will be the value of b, and here is the y, and this is the constant term. Make sure that if the variable will be in y, so you will write the quadratic equation in y variable form, like ay square plus by plus c. It will not be like ax square plus bx plus c. So the value of a will be 2, the value of b will be this one, and the value of c will be the constant term. Okay, let's solve it ahead. Here you can see that since this is a complicated expression, it cannot be solved by midterm partition, so we can apply the alternate method, which is quadratic formula here. So here quadratic formula is applied. You can see here that here we have written y. Here y is written because we are supposed to find the value of y. Now you don't write here the value of x. Y is equal to minus b plus minus b square minus 4ac divided by 2a. This is the quadratic formula. The value of b is written minus as it is. This minus is the value of b, then the value of b, then minus 4a as it is, then the value of c. Minus minus will make plus, so a minus 3b plus minus, then you can see here that minus minus will be plus, and a minus 3b whole square, we can apply the formula a square minus 2ab plus b square. Now you can multiply this sign minus minus because here bracket exists, so bracket shows multiplication, minus minus plus, and 4 2s are 8, and the value of ab and minus b square is written as it is. Okay, here it should be, I think there is a mistake here. You can see here ab plus, it is ab minus b square, so let's make it minus here. This is minus sign, fine. Okay, let's continue now. 4 2s are 8, then ab minus b square. Okay, a square minus 3 2s are 6, then 3 3s are 9, b square 8, ab and minus 8b square here. Now you can see here that a square is written as it is, and minus 6ab plus 8ab will be 2ab, and 9b square minus 8b square will result in b square. 9 minus 8, 1. So here we can see that a square plus 2ab plus b square is a formula, so we can write the shrink form of this. So square root and square can be cancelled, and we have a plus b here. Now we can solve it once with plus and once with minus here. You can see here that a plus a 2a and 3b will be minus 3b plus b will be 2b. Here 2 is common, so we can take it common for for the simplification, and here it's subtracted, so 3b minus b will be minus 4b, and the value of y will be minus b. Here we have the value of y, and we are supposed to find the value of x as well. We have two values of y, so we have to put this both values of y in the equation where x exists. You can see this equation. Okay, we can put the value of y here, a minus b divided by 2. As we can see fraction, so 2 is taken as LCM, so 2a with 2b, and here 2 will be eliminated then. Okay, 2a minus a 1a, 2b minus means b will be minus b, and here will be the value of x. Here again another value of y is written, which is b. So we can write here, and we have the value of x as well. Now we will write this in ordered pair, and this is the solution set. Next question is question number 6. Question number 5 and 6 are similar. So we can go with question number 6. X plus 1 whole square and y plus 1 whole square equals 5. X plus 2 whole square and plus y square equals 5. Here you can see both the equations are quadratic. So how we are supposed to solve these types of equations? Here you can see round bracket. So first of all, you have to eliminate the round brackets so that we can deal the equations. A plus b whole square it can be, so a square plus 2ab plus b square, again a plus b whole square, a square plus b square is equal 5. Now you can see here that you can arrange it. X square plus y square is written first, then 2x, then 2y, then constant term. Quadratic, then linear, then quadratic term, then constant term. 5 minus 2, 3. So this is equation number 3. Now we have to go with equation number 2. Equation number 2, also there is a round bracket, so you have to solve it. So we can see 2x a square plus 2ab plus b square plus y square as it is, then equal 5. Here 2 2s are 4x, 2 2s are 4, and plus y square as it is. Now you have to arrange it. X square plus y square, then 4x, then 5 minus 4 will result in 1. You can name it as equation number 4. Now you can see that we have equation number 3 and equation number 4. Here if one equation is linear and the other is quadratic, so you can derive the value of x from the linear equation and you can put that in quadratic. But if both the equations are quadratic, so you can solve it by solving them all together, means by equating the coefficient or by subtracting one equation from the other equation. Here you can see that both of them are quadratic, and you can see that x square also exists here, x square also, and y square also. So here is that you have to be very thoughtful and rational that how you have to proceed. Here we can reduce the number of terms by subtracting the equation 4 from 3. So we'll choose this method. Here we will go with the subtraction. As you can see that the quadratic terms are cancelled here by subtraction, and we will just have the linear term, so then we can easily proceed then. Okay, minus 4x minus 2x will result minus 2x plus 2y, 3 minus 1 will be 2. Then here we can see that again it can be simplified, so why not to take minus 2 common? X minus y is left and minus 2 is being multiplied, so this side it will get divided, so we'll have x minus y equal minus 1. Here you can see here that by applying this method we have the linear equation. So from this linear equation we can find the value of x, and we can put this in another equation in order to find the value of y. So let's put it here. Put x is equal to y in equation number 4. You can select any of the equation, the one you find easy, you can choose that equation. Okay, we can put y minus 1 the value of x instead of x, y minus 1, and square is above x, therefore square is written, and all these are written as it is. Instead of x, y minus 1 is written, and now y minus 1 is having whole square, so we can apply the formula a square minus 2ab plus b square. Then okay, y square is written as it is, and 4y minus 4 and equals 1. Here we can see that the like terms are added. Y square plus y square will be 2y square, and minus 2y plus 4y will be 2y. 1 minus 4 will be minus 3, and minus 1 to this side of the equation. Minus 3 minus 1 minus 4. Now you can see here 3 terms, and 3 terms can be solved by midterm partition. So by multiplication, what we have to? 4 2s are 8. So by multiplication, we must get 8, and by addition and subtraction, we get 2. So 4 and 2, 4 2s are 8, and 4 minus 2 will result in 2, so 4 and 2 are the factors. Here we can go with the common. 2y is taken common, and minus 2 is taken common from here. Now we will be having means 2 brackets, and 2 brackets can be put equal to 0, and we will be having the value of y, and the value of y will be minus 2 and 1. We can put the value of y and 2 in the equation, in the same equation, in order to find the value of x. So here we have the value of x, which are written in the where the value of x and y are written in the form of ordered pairs in the solution set. Okay, question number 8, equation number 1 and equation number 2 we have. Here again you can see that both the equations are quadratic, so how we can solve it? Okay, but here what's the difference between question number, we can see 6 and 8. In question number 6, if you can see that when we simplified the bracket, so we had same means algebraic terms where the coefficients were also same, but in question number 8 we can see here that the coefficients are different. The coefficient of x is 4, and the coefficient of x square is 3. Then a coefficient of y is 5, y square is 5, and the coefficient of y square is 1. So we cannot convert this in linear form until and unless the coefficients are, or we can say that the coefficients of the variables are made same. So we have to equate the coefficients here. So let's see that whether if you want to equate the coefficient of x or the coefficient of y, up to you. Here we can see that if we multiply the equation number 2 with 5, as we can see that the coefficient of y square is 5, so it will be easy for us. Other than that, if we make the coefficient of x square same, so we multiply equation number 2 by 5 in order to equate the coefficient. So 5 3s are 15, 5y and 14 with 5 well multiplied will result in 70. So now you can write here that this is equation number 3, and equation number 3 and equation number 1 have the same coefficient, means y square has the same coefficient, so therefore we can add this both equation. Why not subtract? Because here is already subtraction sign, here is positive, so they both cancel each other. So adding equation number 1 and 3, so you can see here that one unknown value on one variable is cancelled here, and now we have just x square. So we can easily find the value of x from here by shifting 19 to their side of the equation, and the value of x square will be 4. We need the value of x, therefore we have to eliminate the square, so it can be done by taking the square root, and we will be having x as plus minus 2. We have to put once x2 and once we have to put minus 2 in order to find the both values of y. So you can put x is equal to 2 in any of the equations which you find easy. So I have chosen equation number 1 here, so you can put in equation number 1 x2, instead of x you can put the value 2, for 2 2s are 4, 4 4s are 16, minus 5y square, and you have found the value of y. Same is the case, you can put minus 3 and you have the value of y here. Okay, now we have equation number 10, question number 10, x square plus 2y square is equal to 3x square plus 4xy minus 5y square. Here what is the problem that you can see here? X square is here, x square is here, but you can see here that the second term is 2y square, but here the second term is what we have, minus y square, and then we have x into y, and here we don't have x into y. So means both equations are different. If you see that this here we have the same terms like x square, then y square, then constant term, then constant term, but here we have 4xy in this equation, but we don't have xy this term here. So it means if you come across such type of equations, so what you have to do, here we can see this type of equation where in between x and y also exists. So it means this type of equations can be further factorized by midterm partition. Therefore you have to choose equation number 2. So you can write equation number 2 here, and it can be further factorized by that. By multiplication we get 5, and by addition and subtraction we get 4. So here you can see that 1 is 5, and 5 minus 1 will be 4, and here we have taken common, and we have two set of values, x plus 5y and x minus y. So we can by factorization of this, or by midterm partition of this equation, we can have the value of x and y. So you can recognize this type of the equations when x and y, and in middle again x and y. Okay, now we can put the value of x in the equations in order to find the values of y. So you can put in equation number 1, because from equation number 2 you have found these values. So you can put here, and you can see here that 5 5s are 25, and at the end you will have the values of y. Okay, here, okay, we have two values of x. Here we have the values of y is equal to plus minus 1 upon 3, and y is equal, so we will be having the values of x. Here you have put the values of y. Let me tell you, y is equal to plus minus 1 upon 3, and at the end you have the values of x. Okay, when you have put the values of y, excuse me, you have put the value of x is equal to 5.1 equation, and as a result you got the value of y. Now again you have to find the value of x. So again this value of y is put in the same equation, so you have the value of x and y. Again now we have to put the value of x is equal to y in the equation. In this equation you can see here, and we have the value of y. Then again put the value of y here again in order to have the value of x. Yeah, because these are the values of, these are not the original values of x, these are the values of x in terms of y. So you have to put the value of x from here in the equations. You will have the value of y. Again put the value of y here, so you will have the value of x. Put the value of x here, then you will have the value of y. Then again put the value of y here, so you will have the value of x. So here we can have the values of x and y both. Now we are here, we have question number 12. You can see here, due to limited time I have to be a little bit fast, so I think that you will get the concept. Here you can see this type of equation, how you can recognize x square plus xy equals 5 and y square plus xy equals 3. Both of them are quadratic equation, but here what is the difference, that here x square exists and here y square exists. So you have, means if you will solve this equation by equating coefficients, so you will get stuck here. So you have to recognize this type of equation, that if here different variables exist but here xy and xy are same, so here you can go with taking common. From equation number 1 x can be taken common, and from equation number 2 y can be taken common, and we can see here that we can eliminate this term by division, that if we divide this equation, so this can be divided and we have this equation. Now from it has been converted in easy terms, so the value of x can be y is being divided here, at that side it will get multiplied here. Okay, now we can put the value of x in equation number 1 in order to get the values of y. So here you can see that instead of x, 5y upon 3 is put, and you have solved it. Here you can see that 9 3s means if you will go with the LCM of 9 and 3, so you will get 9 here. So multiply both sides by 9 when you will multiply here. So let's go ahead. Then you will have this equation. When you will add this both, so it will result in 40, and 45 can be brought down as it is. By cancellation you can get y, the value of y, 3 divided by 2 square root 2. Now we have to put these values in equation number in x in order to find the value of x. So both the values of y should be put in this equation, excuse me. Okay, so you will have the values of x here. Now let's go with question number 13, which is the last question. Here you can see that x square minus 2xy is equal to 7, xy plus 3y square is equal to 2. As different at this question, here you can see that you can take common, but here if you just will take common, so you will not get such type of means same terms here for division. So here you will get stuck. Here what you are supposed to do, if you cannot make this same, so you are going to make the constant term same here. So you are going to multiply equation number 1 by 2 and equation number 2 by 7, so that in order to equate the constant term, like 7 2s are 14 and 2 7s are 14, here it's difficult to equate these terms same, so therefore we are equating the constant term. So if the constant terms are same, so here we can go with the subtraction. Here 14 minus 14 will result in 0. 7xy in or 4xy will result in 11xy, and this 21y square is written as it is, and 2x squared is written as it is. This cannot be solved because they are different terms. So here you can see that we can write this in a range form. Minus 2x square is written first, and 11xy then plus 21y square is written ahead. Then you can see when there is minus at the beginning, so you can take minus common, so here all the sign will get changed. And here you can see three terms that if I told you earlier as well that x square y square in between the same variables, of course you can go with the midterm partition here. 21 into 2, okay, will result in 2 1 is to 2 2s are 4. Okay, 21 into 2, 42 it will result. So you have to find such numbers that by multiplication you get 42, and by addition and subtraction you get 11. So 14 and 3s are the numbers. Okay, so 2x can be taken common here, and here 3y can be taken common. So these are the values of x, but these are not the exact values of x because these are in terms of y. But you can put this value for values of x in any of the equations in order to find the values of y here. So here we can see that it's put in equation number 1, and now we can see that we have the values of y. When you will put these values of y, here is the value of y. When you have put this value of y again in the same equation, you can see in the same equation x is equal to 7y. So you have the value of x. Now the next value of x is equal to 3y minus 2. You have to put this in the equation. You can see here you have put in the equation and you have the value of y. Now again put this value of y in the same equation, so you will be having the values of x here. Here we have the values of x. What is done here, whenever you can see here that radical 3 is in denominator, so you can rationalize it. Means if you don't want a non-terminating number, because if you take the radical 3, so it will result in means non-terminating number. So if you want to eliminate this irrational number in denominator, so you can rationalize it by multiplying and dividing it by radical 3. It's not compulsory, but since your answer the back side is in this form, so it's better if you go with this. So here it is rationalized here, and we can see just radical 3, and denominator is rationalized here. So you can write here your answer. This exercise 2.7, and that will be your homework. So I hope that you have understood the concept. Have a nice day. Take care.